So let's look at now some financial type models. And we're going to start just review what we've already done, but this is kind of important. The initial condition of the set of some phenomena that is being described mathematically occurs when the domain value is at 0. In other words, f of 0 equals initial condition. And again, we've already seen that what this means is that if I have f of t equals a plus b, let's say, to the t, if I entered f of 0, what do I have? A to b to the 0th power is a 1, and gives me a. So again, this a is that initial condition that we're talking about here, right? So you invest $4,000 in an account earning 1.9% monthly. Every month you earn 1.9% of the previous amount. Okay, what does a 1.9% represent? So this is, again, you're earning 1.9% of the previous amount. So it looks like I'm multiplying every time by 1.9%. Okay, so again, you've got to think about the structure of how it's being described to you. So this is going to be really R. R is equal to 0.019 in decimal form. So this is the, and again, I'm going up, you earn 1.9%, so I'm increasing every time. So this is the growth rate, because I'm growing. So it's a growth rate, rate meaning by how much I'm going up by. I'm going by 1.9% every month. What does the value of 4,000 represent? This is the initial amount invested. Okay, that's what it represents, initial amount invested. And of course, if I'm sort of looking at a formula that describes something exponential, it is the, again, if I'm looking at something like this, this is 4,000 is the A in this scenario. Okay, what is the value of B? Well, again, what's B? B is the factor. The in this case is going to be, because I'm growing, it's going to be the growth factor. And what is the growth factor? Well, again, remember the growth factor, the B is comprised of 1 plus my growth rate. My growth rate happens to be 0.019. So it looks like it's 1.019 is the value of B, my growth factor. Write an exponential function describing the situation. So again, I put it all together, and I write my, again, just following this template, my initial condition. My B is my growth factor. So I'll write here, and T. And there you have it. Great. So now we're going to get back into this nitty gritty, and we'll keep adding more to what we're already doing. Okay, so this is just kind of review what we've already been doing, but it gives you a nice review for what happens next. So we're going to look at this thing called compounding. Okay, the concept of compounding is an important one, especially when we're talking about finance. It's comes with the ground, the playground, right? So they always tells you to invest early in retirement because of the money compounds. But what is compounding? So all the examples shown so far, except for the one that was linear, except for linear one, contain compounding. The best way to explain this is by contrasting with an example that does not have compounding. All right. So basically, what compounding is, what is compounding? All it says is compounding uses previous gained amount in the next calculation for increase or decrease. Which is what we've been doing. Every time we've increased, we've always used a new amount which contained the amount that was previously gained. But there's another type of an interest called simple interest, not compound interest, but simple interest. And simple interest, only the initial amount is used to calculate the increase. For example, and of course, nobody does this, but well, it could be used, but banks don't use it, credit cards don't use this. Okay. For example, suppose you invest $50 in an account earning 5% in simple interest every year. How much would you have after 3 years? I mean, and this could happen if you take all your gains and every single time you use your gains, you don't let it invest. So that would be an example of simple interest. So, for example, you invest $50, okay, account earning 5% simple interest every year. How much would you have at the end of 3 years? So let's, again, just to illustrate, let's do this F and then call this G of T. So what is happening here? Year 0, you have the $50. Okay. Now, year 1, what's going to happen? You're going to take the $50 and increases by 5%. Okay. And then after that, you're going to add it. That's $50. So it seems at first everything's the same. 5% of 50, that's $2.50 plus 50, that gives you 52. 52.50. Great. So after year 1, you got 52.50. Okay. What happens in year 2? Well, in year 2, what's going to happen is you're going to take and increase the amount by taking 50 of not 52.50, but the original 50. And then you're going to add this to what came before. Okay. So when I do this, what happens? Well, again, in year 2, it looks like I'm going to gain again another 250. I'm going to add this to 52.50, and that gives me $55. What happens in year 3? Well, year 3, again, the same thing. It's 50%, $50 times 0.05. You see it's 250 every single time. And now I add it to what came before. And what I get, again, just to get quickly into this, you can check with the calculator. Yep, 50, just make sure I got this right. Now I'm getting confused. Nope, there we go. 57.50. Okay, so really what's happening is every single time, if I break this down, 50% of $50 times 5% is $2.50. Okay, so every time you're getting 250. But I'm not using the gain amount. So even though I earn 250 the first time, when I do the next calculation, I am not calculating 250. So the interest is not earning interest. So the big thing here is interest is not earning interest. And that's what makes it simple. So after 3 years, I would have 57.50. But in the formula, how does this work? In the formula G of T says, look, I start with 50. And what's happening every single time? Well, look, every time I'm going to increase these by 50, the initial amount times the percentage. So if I were to write this, I'm going to write it without, leave it as is. I'm not going to try and simplify this. This is your formula for simple interest. So this is the simple interest part. So this is your interest part. But again, the interest is not itself earning interest. So it just every year you just recalculate from this initial amount. So this is your interest, this is your initial amount, and that's how you're growing the money. Okay, so that's your interest. So the simple interest formula is always this simple interest. Again, you can look it up. again, and this only calculates the interest. You need to add it to the original amount, but simple interest formula is again the, as I'm going to see, I'm going to call this P for principal, the amount you invest, R and T. That's the simple, where R is your growth rate and T is the number of time that you're going to apply. So it could be in years, it could be in months, it could be weeks, whatever. In this case, it was every year was a unit that we are using it. So another thing to keep in mind is whatever percentage you're being quoted, find the unit that it pertains to, the time unit. Okay. Compare this to compound interest, and in compound interest the interest earned for the previous periods earn interest themselves. So you suppose you invest $50 and account into 5%. How much do you have after 3 years? Again, done this several times now, but let's do it one more time. Again, initially it's $50. If year one, you can gain 0.05 plus the 50. So you see where this is going, where you have the amount from above, 5250. But the difference is the second year, that 5250 grows. And now we're going to do this again, but the amount now is being changed because I am adding 5% of 5250. Okay, so now notice the 250 that I gained here is being calculated as far as the results concerned. So the formula again for this now for this one is going to be my original amount and then 1 plus my growth rate T. So if I want to know how much I get in 3 years, all I need to do is use this formula that I've created. Again, notice how I'm using function notation to communicate what I wrote my initial, I wrote G of T, da, da, da. Now I'm going to tell the reader that I'm going to use insert 3 in here. So this is what I'm expecting you to do as well. So practice doing this when you do your homework, even though you're not turning it in, you still should practice this approach. So again, 50 times, again, I'm just going to write this 1.05. And now the caret symbol is right. Can't see this off the screen, but they use the caret symbol to raise to a power. This is the caret symbol right there. Enter 3. And then I'm just going to write the nearest penny. So approximately $57.88 is what you have.